Hello everyone, it's Benny, and in this video I'm going to show you how you can make your doors actually open. And with any luck, this should hopefully be the last video on doors, and hopefully you can move on to other things. But if for some reason opening doors is so challenging that it requires another video, then, well, what must be done, I suppose. And yeah. Now before I get started, I think it's worth mentioning that this is actually take 2. I tried recording this before, and it didn't work out like I'd liked it to, so I tried my hardest to make all the classes as they were at the end of the last video, but it may have some slight differences here and there. If there are, I'm sorry, but I did try, and that's why they're there. So first off, let's go ahead and add collision back to our doors. I'm going to start with uncommenting the 3 lines of code we commented out in the last video. And really all I'm going to do here is the same thing I did with all the other door things. I'm going to do a for each loop for each door. Door, indoors. And check collisions. And this is not going to work, mostly because some of the doors aren't at proper orientation. I'm just going to add a little big to-do here. Make this take into account the door's orientation. There we go. And with that, I should be able to run now. And I should be able to just run right into the doors. Can't open them. And again, I apologize for the weird, inconsistent frame rate. I still haven't quite got that sorted out. But yeah, we can now run into the doors. And eventually, once we have doors that actually open, I'm going to go in and I'm going to make that, well, I'm going to make this take into account orientation. And now for the big method. Public void open. When we call this method, we want the door to open. So what I'm going to do is I'm going to have a little variable. Here's how I'm going to do this. I'm going to have some private boolean is opening. And I'm going to start with this dot is opening, initialize that to false. And that's all to start off with, that's what the opening method is going to change. Is opening is true. And if it already is opening, then just return. We don't want to change anything. That's all this. Yeah. And sorry, I just got interrupted. Sorry about that. But anyways, so that's all I want the open method to do right now. I just want to set this flag, because in my update method, I'm going to see if the door is opening. And if it is, well, I'm going to need to move the door accordingly. So I got at least the initial framework set up. The only trick now is actually doing it. And there's a lot of ways to do this. I think in the way we have it set up right now, at least, the easiest way is probably just with timing. So that's what I'm going to do. I'm going to create 3... some number of doubles, so private double, for all the different times and events that all sort of like, it's kind of like keyframe animation, sort of like that. That's, except very manual and very rigid. So I have start open time. Well, yeah, start. I'll call it. How about this? Opening start time. This is the time the door starts opening. Private double. The complement. Closing start time. The time the door starts closing. Private double. Open time, the time when the door is fully open, and a private double close time, the time when the door is fully closed. This is going to pretty much work just like keyframe animation. I'm going to set when these times are, and then I'm going to figure out when the positions for these are, and I'm going to interpolate between them. But of course I'm going to have to set all this in the open method. So when I say this is open, then opening start time is going to equal, I want this in seconds, time dot get time over double time dot second. And really, this is something that should, well, this just should be the intrinsic behavior of the time class. I don't think we're doing anyone favors by making the time default to be nanoseconds. So I'm going to add that to the notes. Oh, and I still have the notes from when that I didn't delete. So let's just delete this, and yeah. Make all time based on seconds rather than nanoseconds. So that's going to be our first critical point in time. Next, open time, the time when the door finishes opening. I'm actually just going to say opening start time plus the time to open, which is going to be some constant. And I'm going to create a constant field. It's going to be public. And then, yeah, I'm going to set it to 1 second. I'm just leave a to-do. Make these values appropriate. And I'm going to make it public because, well, I really don't have a good reason not to make it public, pretty much. So, there. Now I know when the door is open. Now, close time is going to equal whatever time it opens at, plus, I'll say close delay. And we'll make that a constant. Again, public, because don't have a good reason not to. I'll make it 2 seconds. And again, I'll need to make that appropriate. I need to make it appropriate. And finally, closing. Wait, I got these backwards. This is what closing start time should be. And close time should equal closing start time plus time to open, because it should be conversely the time to close. And with that, that should calculate all our 4 critical times. And now we just need to interpolate the position. Problem is we don't know what the positions are, so I'm going to need to create a few more fields here. Private vector 3f, open position, and private vector 3f closed position. And I need to set these to something in the constructor. So first off, I'm just going to assume, well, I shouldn't say assume. The closed position is just going to be whatever position the door starts in. It's going to start off closed. So it's going to be transform.get translation. And I want to make a copy of this, so I'm just going to multiply it by 1 as sort of a trick. That should actually be a feature that I didn't actually know, so probably make decent way to copy vector. Why not? Because I don't think I have a constructor that's just like new vector 3f with this, do I? No. So, yeah, actually I'll raise that. Give vectors a copy constructor. There. Much better. The open position, however, is going to be a little bit trickier. It's going to depend on the orientation it's created in, and, well, that's information that's most easily obtained when the door is actually created. So, I'm going to take that in as a parameter, vector 3f, open position. And the open position is going to start as open position. And there. And with all that, yeah, we're going to need to do some things in the level. But with that, we should actually be able to interpolate between the positions. There's just one slight problem, though. We don't have a good way... Well, we don't have a method of interpolation between vectors, which we really should have. So, how about this? Give vectors an interpolation method. I'm just going to write my own private one here, but it should really be part of the vector class, because it's definitely used frequently enough. And yeah. So, without further ado, I'm going to create a private void vector interpolate. Let's actually call it vector lerp, because lerp is a sort of jargon for linear interpolation. And that's what we're doing. It's going to take some vector 3f start pass, vector 3f end pass, and some float lerp factor. Here's the way this is going to work. When the lerp factor is 0, then it's going to be at the start position. Oh wait, it's going to return a vector 3f. When the lerp factor is 0, returns start position. When lerp factor is 1, it returns end position. And anything in between, it will return that much in between them. So 0.5 would be halfway between the start and end. 0.7 would be 70% of the way between the start and the end. And so forth and so on. So here's how I'm going to actually implement this. I'm going to take my end position, minus my start position, so this gives me the difference between them. I'm going to multiply this by the lerp factor. So this will sort of scale the difference between them by however much we're interpolating by. And I'm going to add the start position, or I'm going to add that to the start position. And this does exactly that. Wait, I'm going to return it. Why? Simple. If this is 0, then then whatever the difference is going to be 0, because 0 times anything is 0. Start position plus 0 is the start position, so if the lerp is 0, it gives me the start position, just like I want. If this is 1, however, then this will give me the full difference between end position and start position, and add that to start position. That sort of works like this. X plus, well, y minus x. Well, in algebra, the x's would cancel and just give me y. So if lerp factor is 1, then that would give me the end position. And of course, anything in between will give me something in between. That's what exactly what I'm going for. So finally, let's start actually implementing this method. So I'm going to have to check the keyframes. First off, we have some double time. I need to know what time it is, because this is all about time. So time equals, and it's going to equal exactly the same thing here. I'm going to just measure the current time in seconds. If our current time is still less than the open time, then, well, we're going to have to do interpolation between our open position and our closed position. So, well, actually, first off, float lerp factor. I would need to calculate how much I need to actually interpolate by. And that can be a little bit interesting. Here's how I'm going to do it. I'm going to take my time, I'm going to subtract what time we are now minus the time we started opening, and divide that by the amount of time it takes to open. And this really should give me, put in parentheses and cast to a float, this should give it between 0 and 1, because, okay, I'll bring out calculator for you. Okay, let's say time is 10 and opening start time was 5. So 10 minus 5. If it takes, I don't know, 10 seconds to open, then 5 over 10 is, well, 0.5. I'm halfway there. If I started opening at 5 seconds and it's 10 seconds now, and it takes 10 seconds to open, I'm clearly halfway there. If I'm at 12 seconds minus 5 over 10, then 0.7, because if I'm 12 seconds in and it takes 10 seconds to open, then again. So yeah, that's how the lerp factor is working. And finally, with all that out of the way, I can say get transform, set translation to vector lerp between, closed position is the start position, open position is the end position, and lerp factor is, well, the lerp factor. And actually I'm just going to inline this here, because, well, there's no good reason to put it anywhere else. Put it on a new line, at least, so it doesn't go way off screen, but yeah. And with that, our door will stay open forever, but this at the very least should give us enough to test the door being opened. So, I'm going to go to level. And I'm going to need to do something in input. I'm going to need to test if the player has hit, well, the open key. But wait, I don't have a good way of testing that because the level doesn't know about the player. That's okay. I'm temporarily going to just create the player in-game and send it to the level. But really, eventually I'm just going to have the player loaded in from the level, like I'm loading doors in. But for now I'm just going to pass the player in as a parameter to the level constructor. And I'm just going to do all the input, an update, and rendering of the player and the level class. So actually let's just go ahead and do that immediately. Player.input. Don't have the variable yet, but that's fine. Player.update and player.render. So now it's moved. I've pretty much just moved responsibility for managing the player to, well, the level class. where it should have been all along, but yeah. And this is going to be pretty simple. Just going to have a private player since it's being passed in, and initializer. I'm going to take in the player and just assign it. This dot player's player. So now the level knows about the player. Exactly what I want. And I'm going to do just a hack to test this. If input dot get key down, and oh, what do I want the input key to be? E, because that's sort of like the use key in a lot of games. If the player's pressed the E key, then what I'm going to do is going to go for every door, indoors, and I'm going to do an interesting little check. If door.getTransform.getTranslation minus the player dot, right, it's done with camera, so get position. So I'm subtracting the door's position from the player's position. I want the length of this, and I want the absolute value of the length. I don't want any sign nonsense. Oh wait, I shouldn't have a sign nonsense here. I'm not going to have sign nonsense because, well, this is done with square roots, and that can't possibly have a sign. Nah. Length can't be negative for vectors. Never mind. Never mind. I don't know what I'm thinking. What I'm doing here is I'm taking the distance. I'm subtracting the door's position from the player's position and getting the length of that. That gets me the distance from whatever door I'm looking at right now and the player. If the player's less than, okay, fine, open distance, it's going to be some constant, then door.open. I'm just going to create a constant field, and I'll set it to 1 for now. 1.0f. There we go. Whew. And actually, is that all I need to do? Apparently not. Right. I still need to pass in the open position. And this can be a little bit tricky, so... because, well, it's going to depend on XY orientation and whatnot, so yeah. I'm just going to create a vector open position, set it, start off with it equal to null, and I'm going to pass it in to the door. And depending, and depending on if it's Y door or X door, I'm just going to set it appropriately. So let's see. Y door, that means the door is like one of these, lined on the Y-axis. If it's like this, then the door should actually open on the X-axis. So I want the open position to equal... Here's what I'm going to do. I'm going to get the door's translation, because after all this, it should be, well, correct. And I'm just going to subtract the open position. Wait, what? No. I'm just going to subtract a new vector 3f, and this should be on the x-axis. And I'm going to have 0.9f, just so that, you know, it doesn't... And the reason I'm doing this rather than 1.0 is just so, you know, the door... Actually, this should be really should be a constant, so... Okay, fair enough. Private static, final float, door... Door open movement amount. There, how about that? Is 0.9f. And where was now? I was way down here. Oh, just missed it. There. Door open movement amount. There. It's going to be on the x-axis. What was I saying? I don't remember. I think it was like why I choose 0.9. That way the door, well, you know, stays out just a little. The door doesn't like get lined up perfectly with the wall, because that looks a little bit weird. So, you know, just leaves a little bit of leeway, because the doors in real life don't go all the way into the wall, nor should these. That's not a good argument, but you get what I'm trying to say. And here, same thing except on the z-axis. The open position is going to be whatever the closed position is, minus the open amount in the appropriate direction. And with that, we should finally be able to test this. So, let's run. Sorry, I feel like I've rushed through this whole thing, I'm sorry. That bothers you, but yeah. And, hey! Look at this! The door opens. Ah! Can you imagine? Well, guess you can because you're watching it, but still. Now, these doors don't quite work because the colliders and... Yeah, see the colliders like right here? Don't know how well you can see it from me moving around, especially with this ridiculous lag, but yeah. The door still opens appropriately, it's just the collider's wrong. But yeah. And I can open all of the doors. And... what? Oh, there we go. I might want to increase the distance just a tiny bit. But yeah. So we can open our doors. They don't close, but still, we can open doors. And now the only question here at this point is, do I have enough time to implement closing before the video time, you know, within a reasonable amount of video time? That's the question. Okay, this is making doors close properly, take 2, because my recorder had a complete freak out on me for some reason. Anyways, now we're just going to take advantage of all those different keyframes we set to make the door close properly. So first off, if it isn't before the open time, if the time is greater than open time, and the time is less than the closing start time, so it's after the door's opened, but before we start closing again. Then I'm going to take our transform and set our translation to the open position. Because, and this is just in case for some reason, well, the interpolation didn't quite finish, didn't interpolate that very last frame where it got into position. And yeah, that's a whole... Why is this giving me an error? What do you mean semicolon expected? It's in... Oh, right. Else if, excuse me. Yeah. And technically this is redundant. The time is greater than open time, because if this condition failed, well, obviously it's greater than open time, but I'm just having this here for, mainly for insurance, just in case that I put something else here later on. It's completely unnecessary, and in fact, I probably am better off getting rid of it, but I'm going to keep it there just because. So anyways, now, if time is greater than the closing start time, and you know what, actually I'm going to get rid of it because it is redundant and it's bothering me. So yeah. Otherwise, so if time is greater than the closing start time, but we're still less than the time we finish closing, then we're going to do another interpolation. We're going to interpolate from our open position to our closed position. And our starting factor is not going to be the opening start time, it's going to be the closing start time. And that's going to be that. Otherwise, well, otherwise it's greater than everything, so get transform.set translation to closed position. We're going to put it in the closed position, and it's not opening anymore, so we can just stop. If it's, of course, beyond the closing time, because that's what we mean if it was here. And with that, we should, if I undid all the code changes correctly, put it in proper position, because it should be doing all the interpolation we set it up to do. Very manual keyframe animation. Again, sorry for the ridiculous inconsistent frame rate. So now it should open. Whoops! I forgot, I changed the constant to something ridiculously fast, so yeah, it's like 0.25 or 0.125 or something. So yeah, the door's opening and closing really fast, but yeah, look, the door's working. We got doors that open and close. We can just blast through them like nothing because they open and close really, really fast. But yeah, it's working, which is good. That's what I want. And really, the only thing left now is getting this collider right, which isn't quite right. So I'm going to minimize that to give myself some more space. And here's how I'm going to do this. I'm going to have the door size not just be constant, but I'm going to have it dependent on the door. So I'm going to have some method door.get door size, and it's going to be private method, or public method, but it's going to be part of the door class. So public vector 2D get, it's kind of redundant to call it to get door size, but yeah. And it's going to start off just returning that. Oh, not vector 2D, vector 2F, what am I saying? And I'm going to do this the extraordinarily cheap and lazy way. And I'm going to say if getTransform.getRotation.getY is 90, then I'm going to return it one way. Otherwise, I'm going to return it this way. I know, but yeah, this really isn't about best coding, or this series really isn't about best coding practices now, is it? So, and as it turns out, you could actually just flip those around. I found that out in the last one. I actually had this whole upper system that would rotate them properly, but apparently you can just reverse them and it works fine. And it makes sense now that I think about it, since it is a rectangle. I wasn't really considering that it was a perfect rectangle for some reason, but yeah, as it turns out, that actually works. And now if I run, then I can move in here. Door opens really, really fast. And look, I can't go through this door without it opening. So open, and hey, look, the collider's working. And yeah, if I go over here, look, collider's working properly. But yeah, it's a really cool way of getting it to work, and I hadn't considered it until the last test one. Or maybe I did consider it at some point, and well, okay. It's a method I'm using now, how about that? I don't know the exact details of when I did or didn't come up with a method similar to it, but yeah. And with that, we now have opening and closing doors exactly, well, working brilliantly. And yeah, actually just to, oh, wrong file. Just to show you, I did change it to 0.2. Okay, I was wondering what I did that to. So yeah, I changed it from 1 to 0.25. And I may change it to 3.0 at some point, but for now, 2.0 is fine. Both that doors are working. And yeah, so hopefully in the next video, we'll be able to move on to enemies. We'll be able to get some Wolfenstein SSs in there, running around, looking out for a player, and ready to blast the bejeebus out of them. And it will be glorious. Well, in theory anyways. It might end up being horrible and painful, but let's just hope that doesn't happen. We'll cross that bridge when we come to it. And yeah, so thank you, hope you enjoyed, hope you learned, and hope you're excited for next time, where we will be adding enemies that shoot our player into the game. Thank you, see you then.